And a very good morning back here on Worcester Radio as we get our behind-the-scenes interview underway for this morning with our good friend from the OSU Extension Office, Rory Lewandowski. Rory joining us here this morning. Rory, before we delve into a good morning, happy to have you back in.
Thanks, Ron. Glad to be here.
Well, we're going to be talking today about stored forage production systems and forage quality. On our previous program last week, we discussed the effects of plant maturity, plant respiration, rainfall, and forage varieties on stored forage quality. So today we're going to look at dry hay, baleage, and forage silage production systems in regard to forage quality. So let's begin, Rory, with dry hay production. If rain's in the forecast, how dry does the hay have to be before I can bale it? And on top of that, does the type of bale make any kind of a difference?
Yes, good question. So moisture content of the forage at baling is obviously a very important factor. Forage that's baled too wet is going to mold and heat in storage. And as that interior bale temperature gets above 150 degrees Fahrenheit, the risk of a hay fire will greatly increase. At 175 degrees, hay fire is imminent. Call the fire department. So the maximum safe moisture content at baling depends upon, as you alluded to, the type of bale, somewhat the time of the year, what kind of drying conditions are we getting, and then whether or not a preservative is used. So for hay made without the use of a preservative, those safe moisture levels are 20% for those small square bales, 15 to 16% moisture for large round bales, and 13 to 15% for large rectangular bales. The goal for long-term storage and stability is moisture content of 15% or lower. So the larger, more densely packed a bale is, the less likely it is to lose moisture during storage and achieve that stability. That's why we can get by higher moisture contents with the small squares. They can lose moisture, whereas a really tightly packed, big, large rectangular bale, it's not going to lose much moisture, so we have to be pretty close to that target when we make it.
Rory, if a preservative is used, how does that affect the baling moisture? And also, what type of product works best, and what are the limits of using a preservative?
Well, preservatives allow a forage to be baled at higher moisture content. So again, a rainstorm is imminent. I might allow you to squeeze a few extra hours in there, but they have to be used correctly. And as you alluded to, yes, there are limits. So the most effective preservatives are propionic acid based. Research shows that they are generally very effective at allowing forage to be baled between about 20 to 25% moisture. They're iffier, pretty questionable then, between 25 to 30% moisture, and none of those products are effective above 30% moisture. So the keys to making them work in their effective range include you got to provide enough product, and make sure it's applied evenly and uniformly as the bale is being formed. You need 10 pounds of actual propionic acid per ton of hay at a moisture level between 25%, and you need 20 pounds of actual propionic acid per ton for moisture levels between 25 and 30%. So there's some cost factors in there you have to think about. The other limit is that the effectiveness of these things is going to decrease over time. This is an acid. That means it's going to volatilize and it'll dissipate from the bale over time. If that bale hasn't dried down by that point to that long-term stability, you can still get some molding then later.
Talking again with Rory Lewandowski from the OSU Extension Office. Rory, we've talked about before baleage and silage production systems. They allow forage to be harvested at higher moisture contents. Besides the fact that harvesting at a higher moisture may prevent rain damage, are there any other advantages from a quality perspective? And also, are there any disadvantages to using a baleage or a silage production system?
Yeah, well, there are certainly some potential forage quality advantages to these systems as compared to dry hay production. Those quality losses associated with raking and baling in a dry hay system that are mainly due to leaf loss and leaf shatter, they're avoided or at least greatly reduced when you harvest forage at a higher moisture level. In some cases, the palatability of the forage is improved by these higher moisture levels. That leads to higher intake, better animal performance. Now, the disadvantage of these systems is that you can have some, again, fairly significant storage and feeding losses if they're not managed correctly.
Rory, I see a lot of wrapped bales around the county. I mean, everywhere you go, you see them. What are the keys to making good quality baleage? Are all types of forage suitable for baleage? And as far as limitations, what are the limitations for this system?
Yeah, those are all important questions. So baleage is similar to haylage, silage, in that they're both fermented forages. But a major difference for those wrap bales or baleage is that forage material is not chopped. It's harvested as a long stem forage. So as a result, that baleage tends to go through a slower and more incomplete fermentation process than a chopped silage. What that means essentially is that often the pH is higher than a chopped silage, and that's significant because that pH really affects what types of organisms can grow, how long we can store it, what kind of quality we're going to end up with. So one key to making high quality baleage is to harvest forage at the proper maturity stage and moisture range. Now, because that forage is not chopped, one concern with baleage is overly mature forages. These are forages, they have more fiber, which means they also have less soluble sugars. Those soluble sugars are really important in that fermentation process. So as forages get more mature, if we harvest them too mature and they're not chopped, we're not getting at those sugars, they're in lower content, we're going to get poor fermentation, higher pH. That means it increases the risk of toxin-producing Clostridial bacteria in our baleage. Small grains, such as cereal rye, oats, wheat, barley, they are particularly at risk if they're used for baleage when they're made in that system after we get head formation. So that's one factor we have to think about. Now, the target moisture range is 45 to 55%. Moisture above 67% increases the risk of spoilage organisms like those Clostridial bacteria. And included in that family are botulism organisms. So that's a concern. The other things we want to make sure the bales are tightly packed. Those dense bales are a must. The goal, again, is to exclude air, promote anaerobic fermentation. Finally, wrap your bales with 6 or more layers of a 1.5 mil plastic within 24 hours after baling, and sooner is better. Many producers aim for wrapping within 12 hours of baling. After bales are wrapped, you then have to inspect them routinely, so there's some maintenance here. You have to promptly patch the plastic when holes or tears are discovered. And then for some producers, dealing with the disposal of that plastic would be considered a limitation in this system.
Talking once again, stored forage production systems and forage quality today with Rory Lewandowski from the OSU Extension Office here in Wayne County. And we'll finish our discussion today with Rory with haylage production. How is it similar to baleage? How does it differ? And what are the keys to making good quality haylage, Rory?
Well, haylage is similar to baleage in that, again, it's an ensiled product. It's harvested after the forage wilts, so again, it's that higher moisture feed stuff. However, unlike baleage, the forage material is chopped. The advantage there is it allows the fermenting bacteria to have more access to plant sugars. So in a nutshell, the keys to making a good quality silage product are to harvest at the correct moisture percentage, ideally between 55 to 62%. Chop that forage at a 3/8 inch theoretical length of chop to improve packing. Fill that silo quickly to limit surface exposure to air, and in bunker silos, pack to achieve greater than 44 pounds of silage per cubic foot density. The goal is to reduce air infiltration to the greatest extent possible. Bill Weiss, the dairy nutrition specialist located here at OARDC in Worcester, always says that when you think you've packed enough, pack some more. After that, after you're done packing, then you seal the silo with an oxygen barrier film within hours of finishing that silo filling, and then cover that with a 6 mil plastic cover. All this is done to reduce spoilage. Research has shown that we get a return of about $8 for each $1 invested in sealing a bunker silo. So it's an important practice.
Yeah, it pays off. Rory, covered as always a lot of material in today's discussion, thrown out a lot of different numbers and percentages. If someone heard it but didn't hear all of it, or just missed some of the things we talked about and need to get more clarification, how can they do that?
Yeah, they can contact me at the Wayne County Extension Office. The phone number is 330-264-8722. I'll be glad to answer their questions or send them more information. This program will also be posted on our Wayne County Extension site, courtesy of WQKT Radio.
All right, Rory Lewandowski from the OSU Extension Office joining us once again on today's show. Rory, always good to have you in. Thanks a lot, and we look forward to seeing you again real soon.
Appreciate it, Ron. Thank you.